Electron configuration is the way in which electrons are distributed in the different orbitals of an atom. Before we start this explanation, let's go to a very straightforward and simple tool that you will be using in order to construct any electron configuration, which is a specific type of notation telling us the amount of electrons found in the different orbitals. And this is called Aufbau, after the scientist, Aufbau's diagram. And a very simple way to construct Aufbau's diagram is, follow with me so we learn how to do it mechanically, and then I'll do a little bit of an explanation. We write a column with numbers 1, 2, 7. We continue with another column with numbers 2 to 7. We continue with a third column starting at 3 and continuing all the way up to 7. And then we finalize with one last fourth column going from number 4 to number 7. Now let's stop a little bit and talk about these. This number represents the shell or the main energy level. So it's represented by numbers 1 through 7, which is the main energy level where an electron could be located. Next, we have what we call subshell, or the type of orbital specifically. And these come from their shapes or how they're theoretically modeled in space. And there's only 4 subshells which are usually seen in basic level chemistry, which is S, P, D, and F. So I'm going to stop right there, and we're going to continue building our Aufbau's diagram. The first column will correspond to S. So we complete each of these numbers with S. It's lowercase f, S I mean. And then we continue the second column with P. We continue the third column with D. And we finalize the last column with F. So shell or main energy level 1 through 7. And then subshell is S, P, D, or F, S, P, D, or F. And we're going to stop right there to continue with our diagram, in which we're going to take diagonal lines starting at the top and crossing down towards the left. And these lines tell us the order in which orbitals are supposed to be filled when we draw an electron configuration, okay? So this is a really practical way, theoretical way in which electrons are supposed to be filled as they occupy different energy levels. Before we continue though, we need to know how many electrons can fit in each of the different orbitals. And this is determined mainly by the subshell. So I'm going to write another little diagram right here. S, P, D, and F. And I would tell you, there's such a thing called orientation, in which it tells us how many specific spatial orientations each of these subshells has. That means which way they're pointing in the 3D model. So S only has 1 orientation. P, on the other hand, has 3 orientations. D has 5. F has 7. And you can look these up in the book to have a little bit more of a theoretical support. But what we need to know is that S, P, D, and F have different orientations. S has 1, P has 3, D has 5, F has 7, and they increase, well, they're odd numbers, right? And the last thing I would say is that each orientation can hold 2 electrons. So 2 electrons per orientation. That would mean that any s orbital, 1s, 2s, 3s, 4s, 5s, any of those can only hold 2 electrons. So number of electrons held, maximum. It doesn't mean we have to occupy all of them. And then P, 2 electrons per orientation. P has 3 orientations, it's 6. 5 for D, it's 10 electrons maximum. And F can hold 7 electrons maximum. Not 7 electrons, it has 7 orientations. Therefore, it can hold 14 electrons maximum. So this is a basic introduction, Aufbau's diagram, which puts together the shell, that main energy level 1 through 7, and then the subshell S, P, D, F, and then we know that S has 1 orientation, 2 electrons, P 3 orientations, 6 electrons, and so forth. So I hope that is clear so that we can continue with our explanation. Now, as I said at the beginning, electron configuration is a way in which we arrange atoms, the atom's electrons in its orbitals. So let's go to a very, very simple example, which would be hydrogen. Hydrogen has atomic number 1, and if it's in its neutral form, the number of electrons it possesses is 1, and its mass number is usually 1 because it usually does not have, the most abundant kind of hydrogen does not have neutrons in its nucleus. So in this case, hydrogen only has 1 electron that we need to arrange. And what are we going to do? The first energy, according to our alphabet diagram, the first energy level to be filled, or orbital, is 1s. So we're going to write 1s. And if we go back to this chart, S only has 1 orientation, so it can hold only 2 electrons. Luckily, we only need to write in 1. So we write number 1 up here as a superscript, and this is the basic method, right? So we write the orbital 1s, and with a 1 representing that 1 electron. Helium with atomic number 2, meaning that it has also 2 electrons if it's in its stable or neutral form, and with a mass number of 4, meaning that it has 2 neutrons. It's very simple. Again, we look for the number of electrons, and we look at our chart, and we look, the first energy level is 1s, and 1s, according to our chart that we should start memorizing, is S can only hold a maximum of 2. Luckily, we need 2, so we write 2. Let's try the next element, which would be lithium. Lithium has atomic number 3. Number of electrons in its neutral form is 3. Mass number is usually 7, meaning that it has 4 neutrons. Again, what we want to know is the number of electrons. 1s2. Next energy level, according to our Aufbau diagram, is 1s2, 2s2, 2s can hold 2 because it's an s orbital, so we only need 1. And this is electron configuration. This is very, very simple. We just continue the numbers. Let's try again with an atom that's a little bit higher up, such as sodium. Sodium has atomic number 11. And this means that in its neutral form it has 11 electrons. And its mass number is usually 23, meaning that it has around 12 neutrons. So we go back to our diagram, which we're going to have here as a cheat sheet. So we have 1s, which can hold 2, 2s, which can hold 2, and we're still missing, I need to fill in 7 electrons, so I continue with p, 2p, but according to this, p has 3 orientations, so it can hold 6. 2 plus 2 is 4, plus 6 is going to be 10, and we're still missing 1 electron to fill out. So after 2p, we continue with 3s. 3s could hold 2, but we only need 1, and this is our electron configuration. Okay? If we continue on with other examples, for example, let's try a much heavier atom such as chlorine. Chlorine's atomic number is 17, and that means that in its neutral form, chlorine is going to have 17 electrons. So these are the 17 electrons we want to occupy. So I'm going to do a little cheat sheet to write the little maximum. I'm going to use the pink color as well that we were using, just to remember. S can hold 2 maximum. P can hold 6 maximum. D can hold 10 maximum. And F can hold 14 maximum. Right? This is going to help us as a little cheat sheet to be able to count really, really quickly. So 1s2, 2s2, that gives me 4. 2p6 gives me 10. 3s2 gives me 12. What I'm doing is I'm adding the little pink numbers, right? So 2 plus 2 plus 6 plus 2 gives me 12. So I'm going to draw those really, really quickly. 1s2, 2s2, 2p6, and I'm following the order that we have right here. 1s2, 2s2, 2p6. Then we have 3s2. And finally, what do we need here is, this is 12, so we're still missing 5 electrons. And those 5 electrons are going to continue in 3s2, 3p. Remember, p can hold 6 electrons. We only need 5, so I'm going to do a little number 5 right there. And we're done. This is the electron configuration. Okay? So basically, what we need to do is fill out these electrons in order and try to make this match following this order. 1s, 2s, 2p, 3s, 3p, 4s, and so forth, following these lines from the top corner on the right to the lower corner on the left. Okay? And we're going to stop right there because the next video is going to be dealing with a diagram of orbitals.